Hey everyone, in this video, I will demonstrate how to use box plots or whisker plots to visualize quantitative data sets on Google Spreadsheets and Excel. All right, so in this video, we'll use a small data set that includes 10 data points. So these are the number of nuclear plants of the top countries that are producing or have been producing nuclear power plants. And keep in mind that this data set has already been ordered as a ascending order, right, from smallest point to the highest point. And we know that in order to create a modified box plot, you need some pieces of information. Particularly, those are like the 5 summary numbers: the mean, first quartile, third quartile, maximum number, and median. So these are the 5 summary numbers. And you can see that I have calculated some measures of central tendency, the mean, median, and the mode, right, for quantitative data set. So in order to create a box plot on Google Spreadsheets, it's simple. You want to include first the name, right, of the data set. I would say I call it, could be sample 1, sample 2, or maybe I call it number of nuclear plants data set. And I include the mean, first quartile, third quartile, and the max. You don't need to use a mean, median when creating a box plot in Google Spreadsheet, right? Selecting this columns, one row. Remember that you have to order these informations by order from mean, first quartile, third quartile, and the max in a row. And then you click insert chart. Give you some sort of chart, right? But we don't need this chart. We want to select this chart. It's called, in Google Spreadsheets, called candlestick chart. Here we go. Right away, you have a box plot for this data set. All right. And again, if you want to modify the chart, the titles, for example, you can say the chart title is the number of nuclear power plants in the top 10 countries. Let's say number of countries. That's going to be your title, and so on and so forth. You can change the vertical titles, you can change the horizontal titles as you see fit. But here's a box plot, and you can see that we have the minimum values down here, which is 4. You have the maximum down here, which is 9, up here, which is 99. And you can see that most of the information, right, most of the data points are concentrated in this area, which is low below the chart or on the left of the distribution. It's something a little odd here, right? Because it's all the information is concentrated in one area, the other area is very, very empty. But because of 99, which is very likely that this one is going to be one of the outliers, but that's why the stick extends to the maximum value, even though there's only one, big values on the right side. And keep in mind that if in this case, we can try to create a modified box plot, which excludes all the outliers. So the modified box plot will use the same quartiles, but the maximum and the minimum can be affected by outliers. So how do we create a modified box plot? So the first thing is we need to figure out outliers. And in order to detect outliers, I use the function OR, right? First, I have to create IQR, come up with the lower bound, come up with the upper bound. So the lower bound, right, for a data point to be outliers has to be less than -32, which we don't have to worry about. We don't have any negative value. But the upper bound is 70, which means any data points that is greater than 70 will be considered as outliers. And for sure, we have one here. All right, 99. So we know that 99 is one of the outliers. And we want to create a new summary numbers table that does not include outliers. So the mean will not be affected. First quartile is the same, third quartile is the same, but the maximum will be affected. And in order to determine the maximum that that is not an outlier, then we can use the filter. So it's still max, but and then you use the filter functions. So you filter the same row or the same column of our data sets, right? A4 to A13, but with the condition that A4 to A13 will be less than 70, because anything that is greater than 70 will be our outliers. So we figured out max is 35, makes sense. If you go back to the data set, so the number that is next to the outlier that is not an outlier is 35, so it makes sense, right? And then we can use this new some of the new numbers here in this summary numbers table to create a modified box plot. So you select this information again, insert charge, go to candlesticks, and you have another box plot. And in this case, this is a modified box plot. Put them together so then you can see and you can compare and contrast the two box plots. Put them in the same scale. Cannot be the same scale because you can see that the range of the Y are widely different, right? So this is from 0 to 40. 40 is the max value, and this is from 0 to 100. So the scale of the Y values are not the same, so we can't compare. But anyway, in the modified box plot versions, you don't see the outlier, which is 99, and you only see the minimum values and the maximum values that are not outliers. And you can see that now the graph is a little more balanced, more balanced in the middle of the distributions, right? Distribution is not scaled to the right anymore. Is because most of the concentration, most of the data points are surrounding in the middle of the data sets. But you might wondering, how can we visualize a modified box plot? Because a modified box plot has to include a box plot and outliers, right, as points. And unfortunately, in Google Spreadsheets, I could not figure out how to include the outliers into the same graph. But in Excel, if you use Excel to visualize, to create box plot or modified box plot, you'll be able to do it. Let's try it. All right, so here's the same data sets, but remember that we're in Excel. Same data sets, and in Excel, if you want to create a box plot, again, just select the data set, go to Insert, and here's some graphs that you can pick from. Some recommended graph, which is not something that we want. Columns, no. Lines, no. Pies, no. No. Statistics, histogram could be, and box plots. You can see that right away. You can change the title, number of nuclear plant, let's say, right? And here is the outlier that we're talking about. 99 is an outlier. The minimum is 4, maximum is about 35, and here's the mean. This is the mean of the data sets. So if you click on this graph, and there's some options for you to choose, but if you go to these bars, you can see that there's some options that you can pick from. For example, if you want to show in the points, which are the points that are on the data set, sometimes we don't, right? We don't need to. You want to show the outlier point, and you click on it, it will show you the outlier point. But if you don't want to show the outlier point, then this is the graph that you've seen earlier in Google Spreadsheet. Okay. All right. But then there's another, it doesn't look quite the same. I feel like the first quartile and the third quartile doesn't look quite the same. So then I will go to the quartile calculations. You want to have the inclusive median. So then it will show you this is actually the first quartile and this is the third quartile of the data set. So again, this is a similar box plot compared to the Google Spreadsheets, the one that we exclude outliers. If we want to include the outlier, it's going to be looks like this, and you can see outliers here. Okay, so this is the modified box plot for this data set using Excel. What if you have two samples and you want to visualize two samples on the same graph using box plots? How can you do that? Definitely you can do that in Google Spreadsheets. Let's go back to the Google Spreadsheets. I have different data sets. Here are the two data sets. We'll show you the number of miles UW-Tacoma students travel to school per day, every day on average. I have two samples here of size 50. And on the right side here, I created the two summary numbers for both samples. And then if you want to visualize both samples on the same graph using box plot, you just select sample 1, sample 2, click insert, click on discharge. You can see that here's an example of two box plots on the same graph. And similarly, if you have 4, 5, 10 different samples, you can definitely collect them together and show them on the same graph. So then you can compare and contrast the distributions between samples. You can talk about the mean, median, the mean value, the max value, the first quartile and the third quartile. Right? You see that the first quartile and the third quartile in the first samples, they are quite spread out from 32 to 95. So that means the 50%, the difference between the first quartile and the first quartiles, the first and the third is the 50% of your middle data points of the data sets. How they spread out? Are they spread out or are they concentrated in a smaller area? In the first sample, most of the data point, like the 50% of the data points in the middle of the distributions are a little spread out from 32 to 94, compared to the second sample where the first quartile and the third quartiles, they are a little more concentrated because they are all in between 36 and 88 instead of 32 and 94. And you can see it clearly using these two box plots. The width of the box here is now a little higher than the width of this box here. Mean and the max is the same for these two samples. All right, so in this video, I hope that you learn how to create a box plot for quantitative data sets, how to create modified box plot and on Google Spreadsheets, right? And also how to create a box plot or a modified box plot in Excel.